Hey guys, welcome to episode 21 of Short Bits by Shorty, special edition GI calculations. These will probably be my last set of videos forever. Enjoy them while I last. Because of that, I have a short message for you in episode 23, the enteral nutrition one, minute 23. Check it out. It's a short thank you for listening kind of message. Otherwise, let's get started. So, question number 1. How much 10%? Also, I have a cough drop in my mouth right now, so it sounds like I'm chewing something. It's probably the cough drop. How much 10% weight by volume travel solution is needed to deliver AB's protein calories? 150 grams. So, let's see. Weight by volume. So, 10% weight by volume means you have 10 grams amino acids per 100 milliliters. So 10% weight by volume means by weight you have 10 grams, by volume of 100 milliliters, percentage-wise. 10 per 100 is 10%. Per the nutrition reference sheet on Blackboard, look at the nutrition reference sheet. Per page 2, hospitalized adults need 2 grams per kg per day of let's say protein. She's 75 kilograms, so 2 grams per kg per day times 75 kilograms. The kilograms cancel to leave you with grams per day. So she needs 2 times 75 with 150 grams of protein per day. The kilograms cancel. So we know that proteins contribute 4 kcals per gram. So she needs 150 grams. Times 4 kcals, the grams cancel, give you 600 kcals. That's where we get this. White on white does not give you anything. So, how much of the solution is needed to deliver the calories? AKA 600 kcals. So we know that let's see. 100, which is 150 grams. Okay, so 10 grams gives per 100 milliliters. Now, what if we have 150 grams? That gives you X, solve for X, and you get 1,500 milliliters of the solution. She did this extra calculation on the bottom to see the final percentage volume. This is what they do back in the old days to check their percentages, because they did everything based on percentages. So you probably want to do this. But based on a total volume, of 2,200, that means that 1,500 out of the 2,200... or weight by volume, sorry. So, in terms of percent weight by volume, you're going to do the 150 grams, which is your weight, divided by your total volume of 2,200 milliliters, times 100 gives you 6.8% weight by volume of protein. That's how much protein is in the final bag. I got the 150 because it's 150 grams of protein. So how much protein is in the bag? Well, it's 6.8%. If the final volume was 2,200. The volume travel solution, which is your protein bag, is 1,500. Your final bag volume is 2,200. So out of that 2,200, how much of that is composed of protein, which is 150 grams. So weight by volume wise, 150 divided by 2,200 gives you 6.8% times 100. Number 2, how much 70% weight by volume dextrose is needed to deliver carbs? So you know that 70% weight by volume is 70 grams over 100 milliliters. Let's see. She needed 1,192 kcals from carbs. And you know that carbs contribute 3.4 kcals per gram of carb. Therefore, and you know that she needed 1,192 kcals. So let's see, 1192 kcals divided by 3.4 kcals per gram. Remember, when you divide, you switch units. So 1192 times 3.4 kcals per gram. Kcals cancel. Kcals cancel to give you grams. So 1192 divided by 3.4, 350 grams. That checks out. That checks out. Let's see. So now how much volume is needed? So you know that it's 70% weight by volume, so 70 grams per 100 milliliters. And you know she needed 350 grams. Match the units. Grams go with grams. Solve for X. 500? 500. X equals 500. So what is the weight by volume of that in a total bag of 2200? So in a total bag size of 2200 milliliters, weight by volume wise, you get 350 grams of carbs in a 2200 milliliter bag. Weight by volume wise gives you 15.9%. So 15.9% of the bag size of 2200 milliliters is 350 grams of carbs. Let's see. Now we're gonna fill out the TPN chart. Let's see. So if you, oh man, this cough drop is strong. Watch episode 20 for how I get this. I'm not gonna explain it again. I have stuff to do. Sorry, guys. So, need an explanation of how you get this and this. Watch episode. That's just sloppy. Watch episode 20. This is 21, right? Yeah, watch episode 20. You'll see how I got that. I'm not gonna explain it again. If you need me to explain it again after you watch it in person, let me know. Episode 20. Check that out. That's based on this. Let's see. Okay, now we're gonna fill out the TPN chart. So the daily amount that AB needs is here, which is the same here, over here. This is just to keep track of everything that you need and how much you're adding. This is a TPN chart, well, a simplified TPN chart that hospitals can use. It's pretty simplified compared to what they actually use. But yeah, here it shows you how much of the electrolyte, what electrolytes you're using, so sodium, potassium, calcium, and the types of forms they're coming. So you can find sodium as the chloride salt, the acetate salt. You can find potassium as a chloride salt, the acetate salt, or the phosphate salt. Magnesium as the sulfate salt. The calcium, you want to use it as the gluconate. So match your electrolytes with your formulation and figure out how much you need to add to get your total daily electrolyte requirements. Okay, so first things first, we're going to add the acetate and the chloride. So how many milliequivalents of acetate and chloride are in 1,500 milliliters of 10% amino acid solution? That's a lot of words. Okay. Let's see. So 1 liter of 10% trabasol, which is your amino acid, contains 88 milliequivalents of acetate and 40 milliequivalents of chloride. So the 1500 mils of 10% trabasol delivers how much acetate and how much chloride. So let's start with acetate. So you know that there are 88 milliequivalents per 1,000 milliliters, and a 1500 ml bag would give you how much? Solve for X, 132. Makes sense because it's bigger. So bigger volume means bigger amount. What about the chloride? Easy. So 1,000 milliliters gives you 40, so 40 milliequivalents. And 1,000 milliliters, you need to bring it up to 1,500 milliliters. That would give you, solve for X, that gives you 60. So 60 milliequivalents of chloride. So now we're going to fill in 60 milliequivalents of chloride in the amino acid solution and 132 milliequivalents of acetate in the amino acid solution. So here's your amino acid solution. You're going to do 60 in here, in the chloride, and the 132 over here in the acetate section. Next up, we got your phosphate. So how would you administer 18 millimoles of phosphate using potassium phosphate? So you know from here that the phosphate requirement is 18. You need 18 millimoles of phosphate. So let's see. You're going to use potassium phosphate per the question. Potassium phosphate. So that is 4.4 milliequivalents per milliliter potassium, or 3 millimoles per milliliter of phosphate. So you know phosphate is in millimoles. Check your units. Always check your units. So we're going to use a 3 because 3 is in the millimoles and you're operating with millimoles over here. So we're going to use 3. So 3 millimoles per milliliter of phosphate and you need 18. So we're going to set up our ratio, 3 millimoles per milliliter. You have 18 millimoles per X milliliters. Make sure your units match. Millimoles on top, milliliters on the bottom. Solve for X gives you 6 milliliters. So you'll need 6 milliliters of the phosphate, which is also as potassium. So 6 milliliters of which contains 6 milliliter solution, which contains potassium and the phosphate. So let's see. So we know the phosphate is 18 millimoles per 6 milliliters, but in 6 milliliters, how much potassium is that? Well, as we saw earlier, that it's 4.4 milliequivalents per milliliter of potassium. So let's see, 4.4 milliequivalents per milliliter of potassium equals X over 6 milliliters. That is 26X equals 26.4 milliliters of potassium. When you're putting the potassium phosphate. So recap of what happened. That seems like a lot. Okay, so we needed to figure out how much milliliters of 18 millimoles of potassium phosphate you need. So Since we're operating with millimoles, we're going to start off, and we need to use potassium phosphate. We're going to check out the potassium phosphate row in the table. So that's 4.4 milliequivalents per milliliter of potassium to 3 millimoles per milliliter of phosphate. So since we're operating with millimoles, we're going to use millimoles to figure out how many milliliters of the solution we need to bring me the 3 millimoles. To bring me up to 18 millimoles from the standard solution of 3. So 6 milliliters, I found out 6 milliliters of this 3 millimole per milliliter phosphate solution gives me 18 millimoles. But since the solution is potassium phosphate, that 6 milliliters also contains potassium. So how much potassium do I have in that solution? So in this solution, the concentration is 4.4 milliequivalents per milliliter. Since I have 6 milliliters of that solution, so that's 4.4 times 6 milliliters gives me 26.4 milliequivalents of potassium. So in that 6 milliliters, I have 18 millimoles of potassium phosphate, or 18 millimoles of phosphate, and I have 26.4 milliequivalents of potassium. That's the wrong units, milliequivalents. So I have 18 millimoles of, in that 6 milliliters, I have 18 millimoles of phosphate, which also contains 26.4 milliequivalents of potassium. It's different units, so it might be confusing, but they're different ions, so they might have to operate on different units, but they're pretty much the same. So in that solution, you have both potassium and phosphate, each with their own concentration units. So we're gonna write that down in our table. 26.4 potassium. So here's my potassium, phosphate, 26.4. Potassium phosphate, I needed 18. Check. Fulfilled my 18. Let's not add any more phosphate here, y'all. Okay. Number next. Oh, okay. Looks like I did. This one is supposed to go over here when I figure out how much potassium is in the phosphate. Sorry, guys. Anyways, next question. So yeah, I answered this question 3C already for you using potassium. I just overstepped myself. Sorry. 3D. How much more potassium do we need to give as potassium chloride? Okay, so let's see. Remember, I said I need a total of 90 milliequivalents of potassium. Currently, I only have 26.4. How else could I give it? I could give it as the acetate, or I could give it as the chloride. Let's try giving it as the chloride, because that's what the question's asking. Let's see. Okay. So, let's see. How much potassium do I still need? Remember I said it's 90 minus 26.4. That gives you 63.6 milliequivalents I gotta make up. Let's see. Let's say that I only have potassium chloride available, because drug shortages are the new in. Let's see. Potassium chloride is provided as 2 milliequivalents per mil of potassium to 2 milliequivalents per mil of chloride. I'm solving for potassium, so let's use the potassium, 2 milliequivalents per mil of potassium. So let's see. 2 milliequivalents per mil. Oh, that's just messy. Let's try again. Take 2. 2 milliequivalents per mil potassium, and I need 63.6 milliequivalents. How many milliliters is that? Solve for X. So 63.6 divided by 2 is 31.8. I'm in the IV room. I don't feel like drawing that extra syringe, so let's make it 32. Because let's be real, sometimes we can get lazy. 32, and it's an adult patient, so that 0.2 won't kill him, I hope. Not a failure. 32 milliliters. So I need 32 milliliters of the solution. However, remember, since this operates as a solution with 2 ions, so you have potassium and you also have chloride. You're also providing chloride when you provide the solution. So we're providing 63.6 milliequivalents of potassium. What about the chloride? How much are we giving when we give 32 mils? So, you know that in potassium chloride, your concentration is 2 milliequivalents per milliliter. So, same thing. 2 milliequivalents. 32. Oh. And 64. Oh, wait. Let's pretend I didn't figure that out. Okay, so 2 milliequivalents per milliliter is the concentration. You know you're giving 32 milliliters. Solve for X to figure out how many milliequivalents that is. That's 64. So you're giving 64 milliequivalents when you give 32 milliliters. So let's fill out our table. So 64, 64. So you know you're giving 64 milliequivalents of potassium as the chloride. And then now, as the chloride, you're giving 64 milliequivalents. And that matches. Okay. So now you're done with potassium because 64 plus 26.4 gives you 90. So we're done touching that. Yeah. On to the next one. Okay, how would you administer 90 milliequivalents of sodium using sodium chloride? So, how much sodium do we need? Let's find out. We are gonna need your sodium. 90 milliequivalents of sodium. 90 is the magic number. Okay, so let's see. You want to give it a sodium chloride, so it's asking for how much sodium we need using sodium chloride. So sodium chloride is provided here in a concentration of 4 milliequivalents per milliliter of sodium. So 4 milliequivalents per milliliter sodium. We need 90, so how many milliliters is that? X, solve for X, that is, oh man, I haven't done math in forever. 22.5. That makes sense. 22.5 milliliters. Okay. Remember, you're also providing chloride. So it's sodium chloride. So you accounted for the sodium. Check. What about the chloride? Oh, IDK, man. Okay, so chloride in this solution is provided as 4 milliequivalents per milliliter also. So we know that chloride is 4 milliequivalents per milliliter. You're giving 22.5 milliliters. How many milliequivalents is that? That gives you 90. I did it so fast because it's pretty much the same. If you look at that. 90 milliequivalents. So now we're going to add 90 milliequivalents of sodium and 90 milliequivalents of chloride. So here's sodium chloride, 90. That checks off that box you finished. So 90, you finished 90. Chloride, you're providing 90. There you go. So always account for both ions in solution when you're providing your TPNs. 3F. So how are we going to get calcium? So we need, how much calcium do we need? According to the TPN chart. We need, here's your calcium, 20 milliequivalents of potassium. Let's shoot them up with 20 milliequivalents of calcium. Did I say potassium? Calcium. 20 let's shoot them up with 20 milliequivalents of calcium. Your choices are calcium chloride and gluconate. Since we're using the phosphate, let's try the gluconate. Also, because apparently can't use the chloride because according to this chart, not used, pH instability. So we're going with the gluconate. Got it? Cool. Any questions? Let me know. Oh, okay. So what is the concentration of calcium in the gluconate? So, let's see. Calcium gluconate provides a concentration of 0.465 milliequivalents per milliliter calcium. 0.465. Okay. That's equal to, I need 20 per x. Solve for x. That gives you 43 milliliters. Apparently we're rounding in 5 to 10 milliliter increments. So we could either do 40 or do 45. Take your choice. Also consider calcium phosphorus stability. Looks like we gave 18.6. So it looks like she picked 40 milliliters. She picked 40 milliliters, which gave a concentration of 18.6. How'd she get that? Well, it's a concentration of 0.465 milliequivalents per milliliter. You know that 40 milliliters, solve for x. X gives you, let me check the math for you. $18.6, that's right. So, I mean 18.6 milliequivalents. That checks out. Okay. So she gave 18.6 milliequivalents. Some calcium gluconate. We're gonna fill that in. Which is pretty much done. Pretty much close to 20. Close enough. Close as you can get. Because when you're making these solutions, it can be a pain. Let's see. We already did calcium. What about, next up is magnesium. Right, okay. Magnesium. So, how much magnesium do we need? Let's see. According to the TPN chart, you need, here's your magnesium, you need 24 milliequivalents of magnesium. Alright. 24. What does it come as? Your choices are magnesium sulfate, and magnesium sulfate. Take your pick. Oh, guess we're going with magnesium sulfate. Okay, so that magnesium comes in a concentration of 4 milliequivalents per milliliter. So you know that's and you need 24 milliequivalents. So that's X equals 6 milliliters. So yeah. So you're gonna have 6 milliliters to provide 24 milliequivalents. That checks out. 24. You finish that. Well, let's go finish the TPN chart. Let's check. 16, 90, 64, 26, 18, 24, 18. Yep, those have been finished. Coolio dealio. Alright, what else is there? So that's how you do that. Make sure you always check for, when you add an ion, make sure you're accounting for the other ion in the solution. And check your units, make sure your units match with whatever units you're trying to calculate with. Okay, question 4. Okay, AB is to receive 2200 milliliters of parenteral nutrition with 18.6 milliequivalents per day of calcium and 18 millimoles of phosphorus per day. What's the predicted calcium phosphate stability? Let's see. So you're gonna do this in milliequivalents. So you want to calculate the product of calcium and milliequivalents per liter times the phosphorus and milliequivalents per liter. So your calcium is 18.6 divided by 2.2 liters. 18 times 18 over 2.2 liters. 6, 4, 5 times 8.1. That gives you 69. That gives you 69. So 69 is less than 300. 300 is a magic number for precipitation. So you're good. Your predicted stability is 69, which is less than 300, so okay. Number 5. Remember that if your TPN osmolarity is great, if you want to give something greater than 900 milliosmoles per liter, remember the per liter, you can give it as a TPN. Otherwise, if it's less than 900 milliosmoles per liter, this is slide 42, I think, where I'm getting this information. Slide 42. Less than 900, you can give it as a peripheral parenteral nutrition. So, let's see. Can we give it as a TPN or a PPN? Whatever this is. Okay. So you want to calculate the total osmolarity. Per liter. So we're going to do your amino acids and your dextrose. Let's see. So earlier, okay, let's see. I'm just gonna do this once. So we need 150 grams of your trabasol, which is your amino acid, and your 350 grams of your dextrose. Okay, so I said I need 150 grams of amino acid and 350 grams of my dextrose. I know my concentration. Oh, that's awkward. So per slide 44, check slide 44. Slide 44. My amino acid is 10 milliosmol per gram, and my dextrose is 5 milliosmol per gram. So 150 grams of amino acid. Let's cancel out units. So 150 milliosmol per gram and 5 milliosmol dextrose per gram. Units, grams cancel, leaving milliosmols. But however, you remember you need units, so divide by your 2.2 liters. Your volume is 2.2 liters. Divide by 2.2 liters gives you the milliosmol per liter as your final units. So 150 times 10. Oh, I don't know why I put 150. That's 10. 150 times 10 divided by 2.2 is 682 milliosmol per liter. Dextrose, 350 times 5 divided by 2.2 is 795. USP 795. Tell me what those rules are. I don't know. So, your total solution, your total is 682 plus 795 is definitely greater than 900 milliosmol per liter. The reason we didn't use the electrolyte, so usually, actually pretty much always usually account for your electrolytes. For example, your sodium chloride, your calcium gluconate, your potassium phosphate, because they contribute osmolarity in your osmolarity calculation. So why didn't we do it here? So why not here? Because your sum is already over 900, so why keep adding when you already know you're going to give it as a TPN? Don't waste your time. You have stuff to do, like eat lunch. So, since it's 9 over 900, you're going to give it as a TPN. You can give it as a TPN. You should give it as a TPN. Okay. Here's this last one. Blah, 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 blah. So, I just wanted to show you this because, number one, so you have, oh, I'm tired. 2.2 liters of parenteral nutrition plus your 250 milliliter lipids gives you a total volume of 2,450 milliliters. Or, basically, I just wanted to show you this to show you how you get the volume range for this patient. Let's see. So you know that for age 18 to 65, this patient's 50, I think. You want to give 30 to 35 milliliters per kg per day. Let's see. So that means, remember our patient AB is 75 kilograms. So that means that your fluid range, so how much TPN fluid should you give a patient per day, is dependent on this chart right here. Since he's between the ages of 18 and 65, give him 30 to 35 mils per kg per day, so 30, 35. 35 mils per kg per day. He's 75 kilograms. Units cancel, kilograms cancel. So that gives you 30 times 75, 2250 mils per day. Or, let's see, 35 times 75, it's 2625. 2625 mils per day. So that's how much fluid max you should be giving a patient based on this chart, age range, and the recommended volume repletion or volume supplementation. So you get these numbers by using this chart over here. These match these numbers, 2250 and 2625. Okay, that's that for that. If you have any questions, let me know. As of, be sure to check out episode 23 at the 23-minute mark. The enteral nutrition at the 23-minute mark. I have a special thank you message for you. In the meantime, feel free to subscribe and or leave feedback at pollev.com/CHRISTIANRUI629. Thank you and good luck to the exam.